Hello everyone, welcome to simplify this nice algebraic expression. We have 1 over 8 and its exponent is 1 over 8. So we write this into the simplified form. And first we write this exponential form into the radical form and we write it as 1 over 8 and its 8th root. Okay. After that, we write this as, here we use this formula. If we have a over b and its nth root, we write it as nth root of a divided by nth root of b. Okay, so we use here this nice formula in this term, and now we write this expression as 8th root of 1 divided by 8th root of 8. Okay, so this is 8th root. And now after that we know that 8th root of 1 is equals to 1 and it is divided by 8th root of 8. And after that here we use another nice formula, and according to this formula, if we have 1 over nth root of a, so here we multiplied this term by a to the power of n minus 1 into nth root divided by a to the power of n minus 1 into nth root. Here it is possible to multiply numerator and denominator by this type of term if you have the exponent is, and if you have the nth root, then you multiply a to the power of n minus 1. If you have fifth root, then you multiply a to the power of 5 minus 1. If you have eighth root, then you multiply a to the power of 8 minus 1. Okay, so here we have eighth root, so that we multiply and divide the term by 8 to the power of 8 minus 1. Okay, so here we write this term here and it is written as 1 over 8th root of 8 is multiplied by 8 to the power of 8 minus 1 into 8th root divided by 8 to the power of 8 minus 1 into 8th root. And after that we multiply this 1 by here and it is written as 8 to the power of 8 minus 1 equals to 7, and 8th root divided by, here we have 8th root of 8 multiplied by 8th root of 8 minus 1 is 7 into 8th root. Okay, so after this step we multiply. Here we need another radical formula. If we have a to the power of nth root of a multiplied by nth root of b, then you combine the nth root of both of these terms and we write it as nth root of ab. Okay, so here we use this nice radical formula. So according to this radical formula we write our denominator as 8 to the power of 7 into 8th root divided by, here first we combine its radical and it is written as 8th root of 8 multiplied by 8 to the power of 7. So here you see that we have the exponent of this 8 is 1. And now here we use another exponential line. We know about this line. If we have a to the power of m multiplied by a to the power of n, it is equals to a to the power of m plus n. Okay, because here in this problem I can just get you the step-by-step solution and I can tell us how many laws, how many radical laws or exponential laws we use here. So we just explain or we can just do all the working from this question. So here we need to add the exponent of these two terms, and it is written as a to the power of 7 and its 8th root divided by, here you have a to the power of 1 plus 7 and its 8th root. So this is equals to 8 to the power of 7 and its 8th root divided by 8 to the power of 8 into 8th root. So here we have another radical law. So if you have a to the power of n into nth root, so this n and nth root are gone and you get again a. Okay, so according to this law, we apply this law in the denominator term. So you see here, this 8 and this 8th root are gone, and we get the remaining terms are 8 to the power of 7 into 8th root divided by 8. And now in the next step, here we need more simplifications, so that now first we find the prime factors of 8. So we find the prime factors of 8 by this division method. So we have 2 4s are 8, 2 2s are 4, and 2 1s are 2. It means that we write over 8 is 2 to the power of 3. So now we replace both bases of 8 by 2 to the power of 3. So now when we replace this 8 equals 2 to the power of 3, it is written as 2 to the power of 3, and its exponent is 7, and 8th root divided by 2 to the power of 3. So here we need another exponential law. So according to this exponential law, if we have a to the power of m to the power of n, it is equals to a to the power of m times of n. So we use here this nice exponential law. So we multiply these two exponents, and it is written as 2 to the power of 21, and its exponent and its 8th root divided by 2 to the power of 3. So here we know about another radical law. So you know that if we have a to the power of m into nth root, so we write this expression, this radical term, into the exponential form. Its exponential form is a to the power of m over n. So now we convert this radical form into the exponential form by using this nice law, so that we write this term as 2 to the power of 21 over 8, and it is divided by 2 to the power of 3. So here we use this in a nice exponential law. If we have a to the power of m divided by a to the power of n, it is equals to a to the power of m minus n. So now we use here this nice exponential law, so that according to this exponential law, we move this exponent from here, and it is written as 2 to the power of 21 over 8 minus 3. And now we take the LCM of this exponent, and it is written as 2, and its LCM is 8, and written as 21 minus 8 3s are 24. So that finally we have it is 2 to the power of 21 minus 24 is minus 3 divided by 8. Okay, so we write into the positive form, it is written as 1 over 2 to the power of 3 over 8. So this is the our required simplified form, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.